right. We're almost done for the year. And guess what's made a return? I love this stuff. Okay, so Chapter 7, we're going to start on that. And 7.1 is about square roots, okay? And so there's going to be some vocab on here, and I will be copying that down for you, taking pictures, and as you know, uploading it into your Google under your composition book. All right, here we go. 7.1, square roots. Hopefully, you have your calculator. If not, remember, if you don't have one of these, I just don't know the keys to use, especially on Casio's, or you could use your calculator that's on your iPad. That's fine. Same thing. But we are going to be using the key x squared. We're going to use the second function. So remember, when you want to use that, you're going to hit the second and then x squared to get your square root symbol to pop up on your calculator. Okay? I do not want to start this K and all right thing again, because last video I watched it again, or the last two I was like, oh, no. Too many, Miss Parks. Here we go. All right. I didn't even get a minute. That guy. The technical term for this is called a radical. That is what the actual sign is. Most of you guys call it a square root. That's fine. But the technical term is the radical. Now, what is underneath that sign? That is called the radicand. And I will be referring to these terms a little bit today, especially the radicand. So remember, when I talk about the radicand, I'm talking about whatever is underneath the square root symbol, technical term, the radical. Now, when you take the square root of something, you are actually trying to find a number that when you multiply it by itself, it gets the radicand. There's a lot of times I'm going to be saying a number by itself and that kind of a thing. So when you take the square root of something, you're finding a number that multiplies by itself, or the same number being multiplied twice, to get whatever's underneath the radical, called the radicand. And I will be putting up vocab and definitions, all that stuff in a second. Now, a perfect square is an integer multiplied by itself. And if we're in class, I'd be saying, hey guys, look over there on the cheating wall with the rainbow chart, and it has perfect squares and square roots. They're inverses of each other. And I'd say, okay, we're going to have to memorize up to 25, blah, 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 blah. And so in class, we would have that great resource to look at. But we don't here. So hopefully you do have your calculator, because it's going to help it out a lot easier. All right? So I will be defining these, but a perfect square, you want to think of 1, 4, 9, 16, 25. I know you can go on and on. 36, what's 7? 49, 64, 81, blah, 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 blah. These are all perfect squares because the square root of that number is an integer. Remember, integers, positives, negatives, and 0. Of course, I'd go back to that cheating wall. Hey, guys, look at that cheating wall. And it's that integer strip that was on the far right of the wall, if you guys recall. Yeah, it is the right. It was that integer strip. It had positives, negatives, and zeros on it. Today I have my Harry Potter gear on. I'm going to be switching up to Harry Potter, I think. My butterbeer. If you guys have never had a butterbeer from Universal Studios, it is amazing. It's basically like a butterscotch drink. It's like so good. My Bergen and Berks. Those Harry Potter fans should know where this is. Actually, you can only get this in Florida, just so you know. It's kind of cool. Here we go. Example 1. I'm trying so hard not to say okay and all right. It is ridiculous. But I've got to try this. Here we go. Example 1. It says find the find the two square roots of a number. Okay, and so many of you guys are familiar with saying, oh, there's only just one number. But there's not. And even in my algebra kids, I had to get them in the habit when you guys are doing algebra. When you take the square root of something, there's actually two numbers. But in this book, you're going to see a couple different symbols. And it's a way to let you know of... I said that wrong, but whatever. It's a way for you to know on when to write 2, 1, or none. That's coming. Here we go. So we're going to find the two square roots of 49. Okay, so what number times itself gets you 49? If you want to do it on a calculator, you can do that. But hopefully some of these are guess and check. I want you to guess and check some of these. Hopefully you came up with 7. Because 7 times 7 is 49. But it's asking for 2 square roots. So what is the other integer? I'm going to write that right here. Integer. Positive. Negative. 0. So what is the other integer that multiplies by itself to get 49? And that's negative 7. Because if you multiply 7 by 7, you get 49. And if you multiply negative 7 by negative 7, you get 49 as well. So when you actually take the square root of a number, there's technically 2 answers. It's the positive and the negative. But sometimes you cannot take the square root of a number. And that is when you get into algebra 2. But for right now, in 8th grade, you could take the square root of anything. Sometimes it just may not be pretty. All right, here we go. So then let's go the negative square root of 9/16. Notice I said the negative first because you cannot, this guy right here, you cannot take the square root of something negative right now. This is a big no-no. Yuck. You won't be able to do that right now. Okay, so if you see a negative sign on the outside, we're good to go. Okay, so square root, remember, you're thinking of just a number multiplied by itself. Another way of saying that, the same number being multiplied twice to get this guy. So here's what I do. The sign is there, the sign is in the answer. You don't want to mess with signs. So what you're really doing is you're going to take the square root of 9 over the square root of 16. So you're just going to split it up a little bit. And so we're going to keep the negative, because if they give you a sign, keep it. If they don't worry about it. So what's the square root of 9? So the same number being multiplied by itself to get 9, which is 3, over same number multiplied by itself to get 16. Well, it's right here, guys. 4. So the negative square root of 9/16 is actually negative 3/4. I can also say the opposite of the square root of 9/16, and I'll still get you the same answer. Here's another one. Where'd my towel go? Oh, I just erased that. I will copy it for you later. Then you're going to see something like this. Give me a number. See, this is so hard coming up with numbers on my own because I'm so used to you guys giving me numbers in class, and I don't like thinking of numbers on my own. So let's go that guy. And we've worked with this sign a smidge in the past. So this is the positive and negative square root of 121. And so this is another way of saying, hey, I want the positive integer and I want the negative integer of the square root of 121. Well, just like that last problem, if the problem has a sign, your answer has a sign. So remember, when I write this, I'm just saying the positive and the negative. You could also write it out, positive something, comma, negative something, comma. This is just kind of a shortcut, and you will end up using this sign a lot in algebra. Okay, so we have the positive and negative. Now we're taking the square root of 121. So the same number being multiplied by itself to get 121. Another way of thinking of that, the same number being multiplied twice to get it. If you do it on your calculator, you can find it quick, or if you have it memorized. It's a positive and negative 11. Okay, so rule of thumb. Remember, rule of thumb is something to help you out. If the problem has a sign, your answer has a sign. So just think of it that way. And then they're going to give you like decimals. So looking in your book, and they give you something like this. The square root of 2.25. Well, here's the thing. 2.25 looks really similar to a perfect square that without a decimal, which is 225. And the square root of 225, let's do this on our calculators. Go second x squared. Can you see that? Ah, there we go. So remember, we get the square root with the parenthesis, and then go 225. And you get 15. But this is the square root of 2.25. So there's got to be decimal in there. And so we know it's 15 something with 15, and there's a decimal in there. Hi, cat. Something, okay? Well, we know it's not 15 because that's 225, and it's got to be pretty small. And so I just start moving decimals. So 1.5. So what you could do is you could check it on your calculator. 1.5, and now just hit your x squared key. Da, da, da. Can you see that? Ooh, look at that. Bingo. And you get 2.25. So it actually is 1.5. Another way of checking it is just move your decimal and then multiply it out. So if you went 0.15, that tells you, without even using your calculator, if you use 0.15 times 0.15, that tells you have to move your decimal 2 from the top and 2 from the bottom. So you actually have to go 4 decimals in, which is too much. So make sure that you just double check it. And, use your calculator. Why not? So rule of thumb, if the problem has a sign, your answer has a sign. If it does not, then you're good to go. But if the problem in the directions say write the 2 square roots, then you have to use the positive and the negative. So just double check your directions because, funny thing is I'm asking you to read the directions. Has anybody watched any good movies lately? I have not. I really miss going to the theater. That's one of my favorite things to do. That's okay. We're all being safe. And we're almost at the end of school, and it was like 70 degrees out yesterday, and I sat outside, and I burnt the top of my legs, which looks ridiculous. I forgot to sunscreen them, but I did sunscreen my arms, so that's good. Anyways, moving on. Today's going to go pretty fast. So example 3, evaluate. We haven't seen this in the bit. Hopefully you remember what evaluate means. 3 words. What are they? Do the math. So evaluate, do the math, evaluate the expression. Evaluate the expression. So basically, guys, these are just order of operation problems with square root expressions in them. So we have this guy, and I'm not going to read it until I'm done writing. Here's the thing. See how this 5 is super squished up with the square root of 36? Just like in regular squishingness of math, and if we were in class, we'd be like, hey guys, look at that wall over there. It's the purple poster, the second row, whatever. No, actually it's the top. It's the top one, I think. Anyways, when things are squished, remember they are still being multiplied, even though there's a square root symbol in there. That's okay. So this is actually saying 5 times the square root of 36, and then we're going to add 7. Okay? So when you have expressions that you have to evaluate with the square root symbols in them, you're going to do that part first. So, okay, so let's take the square root of 36. And you can calculate, you can guess and check, I don't care. But the square root of 36 is 6. So we have 6 plus 7. Remember, this is saying 5 times. So you end up with 5 times 6 plus 7. Order of operations, remember, work left to right when you have inverses, but you always have to follow your PEMDAS. So parentheses, nope. Exponents, nope. Multiply or divide, yes. So we're going to do that first. So that was a very fast reminder on PEMDAS. So 5 times 6 is 30. 30 plus 7, 37. Okay. Here we go, another one. I don't even know if you guys catch it, but I do, and it drives me crazy. 1/4, also known as a quarter, so if you want to change this to a decimal, you can, because I don't care, plus the square root of 18 halves. All right. Seriously, I just need to stop. Hello. Here we go. We're going to do this guy first. Here's the thing. Sometimes it's kind of tricky because you don't have perfect squares under here, and sometimes you have, like, more order of operation kind of stuff. So what you're going to do is you're going to want to do this division of 18 divided by 2 first. So you have 1/4 plus. Now what is 18 divided by 2? Hopefully you got 9. So you have plus the square root of 9. And then go ahead and take the square root. Okay? So you have 1/4 plus the square root of 9, same number multiplied by itself to get 9, which is 3. So now you have 3 plus 1/4. You can keep it as a fraction. I don't care. You can move it as a decimal. I don't care. And you have 3 1/4. Also known as 3.25. So on this guy, do the division. Here, let me... Ooh, I brought out my other pens today. I have more colors. Right here. Do the division first. Jeez. I caught myself. I almost said something, but I caught myself. I'm feeling better about this. This next one is one of my favorite things because it's kind of fun. And in class, I'd have you guys argue. I really miss you guys arguing in class. I just kicked my cat. I feel bad. You're okay. Yes, you're okay. Here we go. Parentheses. The quantity of the square root of 81 squared minus 5. Well, you got to follow your order of operations. P, parentheses. You're going to do the parentheses. So inside the parentheses, you're going to take the square root of 81, which is 9. So you have parentheses 9 squared minus 5. So parentheses. Now there's nothing more to do in the parentheses. Now we can move to the exponents. So we have the quantity of 9 squared. So 9 times 9 is 81 minus 5. Hopefully you guys noticed something. Hopefully you guys went, hey, Miss Parks, this is kind of the same thing as up here. Yes, it is. So 81 minus 5, 76. So if you haven't noticed, a square and a square root undo each other. They are inverse operations. So another way you could do this, or write it out again. And this will, whoops, I ran out of room. This is probably going to be the way that you show this work next year when you guys are in algebra or whenever you guys take algebra. Since a square undoes a square root, which we kind of already did a little bit earlier in the year, I don't even recall, I'm not even going to try. These cancel each other out. So I'm just going to cross those out. And I have 81 minus 5. And oh, look. Same answer. I don't care which way you do it, but you get the same answer. La-di-da. So, that's it for today. Tomorrow is going to be very similar. It's going to be cube roots. So it's almost the same thing, except for the same number being multiplied twice. Or a number times a number times a number to get a cube root. And we worked with cube roots a smidgen when we had, what was it, volume of a sphere. So it's going to be very, very, very similar to this one. Okay, guys, homework. You can use your calculator. I don't care, okay? But it's a quick, easy way of checking to make sure that you did it right. So I hope you guys are well. Have a fabulous day. Go out and photosynthesize yourself, please. Please. But wear sunscreen. Learn from Miss Parks and not just math.